Swayam Prabha. Digital India. Educated India.
Now, we have discussed that for a set of inputs with the help of fuzzy inference engine. So, we will be able to find out which are the rules which are going to be fired. Now, supposing that, so these two rules are going to be fired, and here we have got the membership function distribution for the inputs and outputs. Now, let me read the rules, and supposing that these two rules are going to be fired, and we will have to find out the output of these two rules. Now, the first rule is nothing but if S1 is A1 and S2 is B1, then A prime is C1. Now, let us see how to represent in the figure. So, this particular rule. Now, here, so this indicates actually the first rule. If S1 is A1, so this is nothing but the membership function distribution for A1, and this is nothing but the membership function for your S2, and S2 is B1, then A prime is C1. So, this is nothing but the membership function distribution for your the output. Now, let me repeat. So, if S1 is A1, if S1 is A1 and S2 is B1, then A prime, that is the output, is nothing but C1. So, this indicates actually the first fired rule. Similarly, the second fired rule, if S1 is A2, so this is nothing but the membership function distribution for A2, and S2 is your B2. So, this is nothing but the membership function distribution for B2, then A prime is C2. So, this is nothing but is your C2. So, the second rule is actually represented by so this particular part of the figure. So, this is the first rule, first fired rule, and this is the second fired rule, and supposing that I am passing one set of inputs, the inputs are nothing but S1 star and your S2 star. So, this is the set of inputs. So, this is nothing but 2 input 1 output process. Now, here I am just going to pass. So, this S1 star, that is the first input. Now, if I pass this particular the first input, so corresponding to the first fired rule, so I will be getting one membership function value here, and I will be getting another membership function value here, and corresponding to this particular S2 star. So, I will be getting one membership function value here, and I will be getting another membership function value here. Now, we concentrate on this particular the first rule. The rule is as follows: if S1 is A1, so here I will be getting some membership function value corresponding to S1, and S2 is B1. So, here corresponding to this S2 star, so I will be getting some membership function value, then A prime is C1. That means, this is nothing but the membership function distribution for this particular the output. Now, here once again if you concentrate on the rule 1, the first fired rule. So, here we have got one AND operator, and AND operator is nothing but the minimum operator. So, this is nothing but the mean operator. So, what we do is, so to find out the output of the first fired rule, so we compare, so this particular the mu value and this particular mu value. So, this mu value is corresponding to S1 star, and this mu value is corresponding to your S2 star, and we compare these two mu values, and we try to find out the minimum, because we have got the AND operator. So, if I compare, so this mu value and that particular mu value, so this is the minimum. So, corresponding to that I can find out. So, this is nothing but the fuzzified output corresponding to the first fired rule. Now, by following the similar procedure for the second fired rule, which states if S1 is A2, if S1 is A2 and S2 is B2, then A prime is your the C2. So, this indicates the second rule. Now, corresponding to this S1 star, so I have got this particular membership function value, and corresponding to this S2 star, so I have got this particular membership function value, and now I will have to compare. So, this numerical value of membership and this numerical value of membership, and if I compare, so this is found to be smaller and there is AND operator. So, we will have to consider the minimum value of mu, and corresponding to that minimum value of mu. So, I will be getting some output here, and this shaded portion is nothing but the output of the second fired rule. So, we have got the output of the first fired rule, we have got the output of the second fired rule. Now, we will have to combine. Now, to combine this particular output, we take the concept of the OR operator. Now, in the rule base, supposing that we have got a large number of rules, say there are 9 rules. So, we say that either the first rule has got fired, or the second rule has got fired, or the third rule has got fired, and so on. So, there is one OR operator in between the rules, and that is why if we want to combine, so these two outputs, so what we are going to do is we are going to use the OR operator, and by OR operator we know that this is nothing but the max operator. So, what we do is we superimpose, so this particular shaded portion and this particular shaded portion, and we try to find out the maximum. For example, say, so this particular thing I have copied it here, and this particular the shaded area, so I have copied it here. Now, if I just try to find out what should be the combined control action, the output of the combined control action is decided by, so this particular the output. So, this is actually the area that indicates the combined control action considering both the fired rules. So, this is the way actually we combine the output of the two fired rules using the OR operator. Now, you see, so this particular output is nothing but actually the fuzzy fired output. So, this is an area, and corresponding to this particular area, so we will have to find out what is the crisp value, and that is why we will have to go for some sort of the defuzzification. So, if you see like whatever we discuss, the same thing I have written it here. So, let me just read it out. Now, I am passing S1 star and S2 star. So, these two inputs, and corresponding to this S1 star and S2 star for the first fired rule. So, I will be getting the firing strength, and that is nothing but the minimum of mu A1 S1 star and mu B1 S2 star. This I have already discussed, and you will have to find out the minimum of these two mu values, and that is nothing but the firing strength of the first fired rule. Similarly, the firing strength of the second rule. So, we can find out. So, using this particular the expression, that is alpha 2 is nothing but the minimum between mu A2 S1 star comma mu B2 S2 star. So, we are going to compare these two mu values, and we will try to find out the minimum. So, this is the way actually we determine the firing strength of each of the fired rules. And once you have got that particular the fired rules, the firing strength, now we are going for combining. So, we try to find out the combined control action considering both the fired rules, and as we have already discussed that we take the help of some sort of max operator, and that is nothing but the OR operator. and using the concept of max operator, which I have already discussed. So, we can find out what should be the output, but this particular output is nothing but the fuzzified output. So, we will have to take the help of some sort of the defuzzification. Now, we are going to discuss the defuzzification methods. Now, if you see the literature, we have got a number of methods for defuzzification, and I am just going to use 3 methods for defuzzification, which are very popular. Now, here the first method is the center of sums method. Now, according to this particular method, the center of sums method. So, what we do is, supposing that we have got 2 fired rules. Now, for the first fired rule, supposing that I have got, so this type of the output, that is nothing but the truncated triangle, and for the second fired rule, supposing that I have got, so this type of output, that is another truncated triangle, and of course, here there are some numerical values, here. So, those things I am not writing. Now, supposing that I am getting this particular truncated triangle corresponding to the first fired rule. So, what I am going to do is, I will try to find out what is the area of this particular the truncated triangle or the trapezium, and what should be the center of area denoted by the C1. Now, for this trapezium, very easily we can find out the area. Now, if I know, so this particular dimension say A, and if I know, so this dimension say B, and if I know this H, so very easily I can find out that A1 is nothing but half A plus B multiplied by H. So, very easily can find out what should be the area of this particular the trapezium, and what should be the center of area along this particular direction. The center of area from symmetry I can find out. So, this could be the center of area. So, actually this along this dimension, so this is going to indicate the center of area. Truly speaking, the center of area could be here, and along this the direction of B. So, along the variable, so I can find out this particular the numerical value. So, I know this particular A1 and C1, and following the same procedure, so I can also find out what is A2 and what is the C2. And once you have got this particular A1 C1, A2 C2, so very easily we can find out the crisp output, that is denoted by U, and that is nothing but is A1 C1 plus A2 C2 divided by A1 plus A2. So, this way is going to give the crisp output. Now, here in this mathematical formulation, in this formula form, actually I have used a slightly different notations. So, it indicates the crisp value, that is U prime f prime is nothing but summation j equals to 1 to p a alpha j multiplied by f j divided by summation j equals to 1 to p a alpha j. Now, this a alpha j is going to indicate your A1 and A2, and this f j, that is going to indicate your this C1 and C2. So, using this particular expression, so you can find out actually what should be the crisp output. Now, if I just go back to the slide, so I can find out. So, if this is one area, so I know this area and center of area, this is another area. So, I know the area and center of area. So, this will be actually the crisp output. So, we can find out the crisp output, and while controlling the process, so we will have to depend on so this particular the crisp output. So, this is actually the way the center of sums method work. The same thing actually I have explained here. So, this area, this particular figure has been used to explain that center of sums method, which I have already discussed. So, center of sums method I have already discussed. So, this is the center of sums method. Now, I am just going to discuss another technique, and that is called the centroid method. Now, here actually what we do is we take the help of the centroid method. Now, the combined this output. So, this particular output that is divided into. So, this is actually the output of the combined control action. So, that is divided into a few subregions, very standard subregions. So, what I do is, so this whole area that is divided into a number of subregions. So, this is nothing but the first subregion, this is nothing but the second subregion, this particular triangle is nothing but the third subregion, this your rectangle is the fourth subregion, this particular rectangle is the fifth subregion, and we have got a triangle that is the sixth subregion. Now, for each of these particular subregion, so very easily you can find out what should be the area and the center of area. For example, say if I consider, so this particular triangle. So, if I consider, so this particular your triangle that is denoted by 1, and very easily I can find out what is the area. So, if I know this particular dimension say A, and if I know, so this particular dimension say B, so very easily I can find out. So, the area, and this area is nothing but half into A into B. So, this is nothing but is your area for this particular the triangle, and the center of this particular area can be determined very easily. Now, if it is A, if the total dimension is A, so if I just try to measure from here, so this will be 1/3, 2/3. So, this will be 2/3. So, this will be your 2/3 of A, and this is nothing but is your 1/3 A. So, I can find out the center of area very easily for this particular the right angle the triangle. Now, if I have got one say rectangle, so very easily I can find out this particular area. If I know this particular dimension say A and B, so area is nothing but A multiplied by B, and very easily I can find out the center of area. Now, if I have got, so this type of triangle, for example, say this type of right angle triangle, and I am measuring from this particular side. So, what I will have to do is, if this is A and if this is your the B, so very easily I can find out the center of area could be here, and this is nothing but is your 1/3 A, and this is nothing but is your 2/3 A. So, 1/3, 2/3 A you can find out. So, either we have this type of triangle, or you have got this type of triangle, or you have got this particular the rectangle, and we can find out for each of these particular subregion what is the area and what is the center of area. Now, once you have got, so this area and center of area, so what you can do is, now you can use this centroid method to find out what should be the crisp output. Now, the crisp output, that is nothing but u prime f prime is nothing but summation I equals to 1 to n a I multiplied by f j divided by summation I equals to 1 to n a I, where a I is nothing but the area of ith small region, and f j is nothing but the center of area of tth small region. Now, I have already discussed how to determine the area and the center of area for each of these regular subregions, and once you have got those information, so using this particular formula, so I can find out what should be the crisp output considering all the combined outputs. So, this is the way using the centroid method. So, what you can do is you can find out the crease value, and that is nothing but your the control action. Now, I am just going to discuss another method, that is called the mean of maxima method. Now, the mean of maxima method, so I can explain with the help of this figure very easily. Now, let me repeat that considering both the fired rules, supposing that I am getting this type of the fuzzy fired output, and this shows actually the combined output of your both the fired rules. Now, our aim is to find out a crease value. Now, what we do is we start from here and try to move in this particular direction, and we try to find out the value of mu considering this combined control action, this fuzzy fired output. So, if I move, if I am here, so this is nothing but my mu. Now, if I am here, so this is nothing but my mu. Now, if I just follow, so this particular principle that starting from here, so I am just going to move along this particular the direction, the value of mu is going to vary, and corresponding to this particular value of the variable. So, I will reach the maximum value of mu, and after that it will remain constant. So, this will remain the same up to this value of the output variable. That means, starting from here up to this, the value of this mu will remain constant, and that is the maximum value of this particular the range for getting the maximum value of the mu, that is the membership value. And after that mu is going to be reduced, then once again it will remain constant and it is going to be reduced. Now, we try to find out the range for the output variable, where the mu reaches the maximum. Now, here it reaches the maximum, and after that it will remain the same up to this. That means, from here to here in this particular range, the mu will reach the maximum and that will remain constant. So, we try to find out a range for the output, where we get the maximum value for this the membership, and once you got this particular range for the output variable for which we get the maximum value for the mu, we try to find out the center of this particular range very easily. So, we try to find out the midpoint of this particular range, and that is nothing but the crisp output. So, this is the way actually we try to find out your the crisp value corresponding to the fuzzy fired output. So, these three methods are very popularly used, very popular to determine the crisp value corresponding to the fuzzy fired output. And let me repeat, the first method is just your center of sums method. The second method is the centroid method, and we have got the mean of maxima method. Now, if I compare, so these three methods, now question may arise, out of these three methods which one is the best. Now, it is bit difficult to say which one is the best, but if you see in terms of the computational complexity, the mean of maxima method is computationally the fastest one, and this your center of sums method and the centroid method will be difficult in terms of computation, particularly if I consider the nonlinear membership function distribution. Now, supposing that I am just going to consider say one Gaussian distribution as the membership function distribution for the output. So, this is nothing but the Gaussian distribution for the output variable. Now, supposing that I have got, so this is one Gaussian, there could be another Gaussian here, and let me consider for simplicity only one Gaussian. So, what you will have to do is you will have to find out what is this particular the area, and if you want to find out the area of the shaded portion, so there is no way out, but you will have to take the help of integration, because this is actually a nonlinear one. So, I will have to find out the area of this particular shaded portion, and we will have to take the help of integration, and integration it is computationally very expensive, and that is why the center of sums method and the centroid method are computationally very heavy, and we can rely on this mean of maxima method. Now, I am just going to come back to the same query, that out of these three which one is the best. The way I answered, that it is bit difficult to declare that this is the best. The reason I am just going to tell you, I am just going to take a very practical example just to understand that it is bit difficult to declare which one is the best. Now, let me take this particular very practical example. Now, this particular course I hope will be taken by some undergraduate students also. Now, supposing that after completing your degree, so you are going to join some industry, and supposing that say in a particular organization there are 10 people. So, 10 people have joined at a time, and these 10 people supposing that are coming from 10 different institutes, say x1, x2 up to say x10. Now, they are different, the institutes are different, and 10 people have joined, 10 graduate engineers have joined a particular organization. Now, your performance is going to tell you the output. So, your output will be decided by your performance, whether you are coming from the institute x1 or x2 and or x10, that is not the thing which has to be considered. The main considerations would be your performance, your output. The same is true here. Whether you are using the center of sums method or centroid method or mean of maxima method, any one is good, because based on that we are going to develop the database and the optimized rule base, so that this particular fuzzy reasoning tool is going to give you that output for a set of input as accurately as possible. So, based on this particular method of defuzzification, whether it is center of sums method or centroid method or mean of maxima method, we are going to optimize, we are going to determine the knowledge base of the fuzzy reasoning tool. And in fact, whether we are following a mean of maxima or center of sums method or centroid method, that is not the thing. We will see the performance, like the whether the fuzzy reasoning tool or the fuzzy logic controller is going to, or it is able to determine the output for a set of inputs accurately or not. So, that is actually the performance of this fuzzy reasoning tool, and we are interested to get very accurate modeling for this particular input output relationship of a process. Now, how to ensure that I am going to discuss in the next lecture. Thank you.